Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Rowell and Francois.
I am joined here today on a special recording with Bob Friday, the CTO and co-founder of Mist. He has had a lot of experience in the Wi-Fi industry, and because this is the 20th year of Wi-Fi, happy birthday Wi-Fi, we want to talk about the history of Wi-Fi, how it's progressed over the years and where it's going. And so we have Bob Friday here to talk about that and have a conversation around his experience, his story, and where he thinks Wi-Fi is going in the future. Bob, welcome to the podcast, Clear to Send. Thank you for joining us here today. Why don't you introduce yourself to those who don't know who you are?
Yeah, thanks, Rowell. Yeah, Bob Friday. I started my wireless career at a little company called Ricochet Metrocom back in the early 80s. And that adventure was really about, how we could really, that was back in the early internet days, how we really connect these first browsers that were coming out. After the Metrocom adventure, I started a little company called Airspace. And that was kind of all around the controller adventure, right? Airspace, Aruba and everything. That adventure was really around trying to help IT guys take care of those first wave of Wi-Fi access points that were coming into the enterprise. And then after that, Cisco acquired Airspace. And then I was the mobility CTO at Cisco for around 8 years. And that adventure was really around trying to help move the industry forward in a big company, working on things like Hotspot 2.0. And then of lately, I left Cisco back in 2014 to start Mist. And the Mist is really around the paradigm shift of kind of moving from a nice to have into more of this, Wi-Fi is becoming this must have. So that's kind of a thumbnail sketch of my career and how I got into my wireless adventure.
I think that's quite the condensed version, being that you've got a really extensive, years of experience in wireless. Being that we've reached 20 years here, what are you guys doing to celebrate the 2 decades of wireless connectivity? Do you guys celebrate, or do you just go, wow, we've made it far?
Yeah, I think for me personally, this is what I call a smell the roses moment. You look back, it's hard to believe 20 years has gone by. In that 20 years, I've raised families and watched the whole wireless industry kind of move from this nice to have to must have, and watching the whole enterprise customers dealing with the transitions in their user base. I would say for me, I make a barrel of wine a year. So for me, the 20-year anniversary was really a nice sip of wine to celebrate a 20-year adventure.
Wow. And I've heard of the story of you making your wine. I'm sure you've got your special 20-year Wi-Fi edition of wine, and you're casually sipping on that.
Yes. Anybody who wants to enjoy a little Mist Estate, they're welcome to come over.
Oh, there we go. And you talked about how you got started with this startup long ago. Can you take us back and go into when you first got into this technology? Like, what was that like for you getting started with wireless?
Yeah, for me personally, for those who remember back in 1985, so I came out of school in the early 80s, and so Metrocom Ricochet was my first startup adventure, and 1985 was a critical year for me in 2 ways, right? That was the year that the FCC came out with the unlicensed ban, right? And that's kind of, I would say, the start of kind of Wi-Fi, right? Is when the FCC opened up the spectrum to all users. It was also the year I was a software engineer back then. I really didn't know much about wireless. I started at Metrocom, and I actually found, it's kind of an interesting story, I found out that you can almost do anything you want to do. That's back when, they were still laying out tapes, right? We laid out Wi-Fi boards. And what I figured out quickly in my career was that I could lay out a board. That's when those first CAD systems came out. I could lay out a board, turn it, and basically get a radio built in about 6 weeks. So that was kind of the beginnings of my wireless career back at Metrocom. where we're basically using these unlicensed spectrum, started with actually trying to help the electrical companies do smart meter reading, right? We're building big mesh networks to read meters on your houses back then.
Okay. And it's still kind of similar to today. I mean, they're still doing these, I guess now that would be considered IoT devices, right?
Yeah, no, if you think back in the early 80s, and that was back when we were just starting the whole frequency hopping versus direct sequence, right? The unlicensed rules that just came out, they had written these rules, and there was really two ways to do spread spectrum. Either you were going to do kind of the hopping approach, or you were going to do more of the direct sequence approach. And, you kind of see how things evolved, right? Eventually, direct sequence is what kind of won out in the Wi-Fi world.
And when you're first starting to look into these wireless radios, and putting them on these boards, how did you guys analyze or interpret, like reading through the actual document there, the IEEE doc? How do you guys interpret that? Like, I know I've read it, I've looked through it, and it just goes over my head sometimes. And it's a complicated document. Understanding it is not an easy task. It takes a lot of, I would say, a lot of education to even understand some of the formulas they have there. Like, how do you go about reading these IEEE documents?
Yeah, when you think back, it really started with the FCC documents, right? You really had to understand the FCC rules, what they really called spec spectrum, right? And if you look back in the early Wi-Fi days, it really came out, how do you actually meet these rules? And so that's kind of how the IEEE protocol started with, right? Trying to create a protocol that could actually meet the spec spectrum requirements of the FCC.
Okay.
Past that, once you got into that, then it became about, there was kind of the modulation, right? The layer 0, how do you actually modulate a waveform that meets the rules? And then we really got into kind of how do we actually build something that looks like Ethernet, right? And if you look at the difference between what I would call the 3GPP, kind of the cellular world, right? And if you look at the Wi-Fi world is really born out of this IEEE best effort. We're going to deal with a lot of interference, right? That's that whole collision. I don't know if you remember the collision sense multiple access.
Yeah.
We're basically going to be putting packets on, and you remember it came out of the Ethernet world, right? It came out of this IEEE world of we're going to put packets on a cable, and we're going to detect. And before we put a packet on the cable, we are actually going to make sure that the coast is clear. If you look at a cellular type of protocol, that's a much more deterministic protocol, right? It's all scheduled, right? There's no look. It's like everything is timed. No one gets on the air until you're actually allowed to get on the air. So that's kind of where you look at the very roots of Wi-Fi, and you kind of see that, right? There's two different worlds. There's a 3GPP world, which is a very deterministic schedule world, and then there's kind of this more IEEE Wi-Fi world, which is much more statistical in nature, if that makes sense.
Yeah, and looking into Wi-Fi 6, we're kind of headed that way with the AP now gaining a lot of control and being able to do things like scheduling, because we do have OFDMA, which we've borrowed from the cellular world. Am I correct in that statement? Are we getting closer to how cellular works?
Yeah, no, I think if you look at the two worlds, right? If you look at the IEEE 3GP cellular world, they are tending to converge. Interesting enough, I guess I would have said that the Wi-Fi world, the Wi-Fi protocols have actually been a little bit ahead of the cellular protocols in terms of fundamental modulation techniques. And that just tends from the environment they're working in, whereas Wi-Fi has been working more of an indoor short range world, and cellular has been working more of an outdoor longer range world. The protocols themselves is, they've been they've been coming together for the last probably 10 years, right? Cellular started in this very scheduled world. Wi-Fi is moving to much more of a scheduled type of protocol, right? You do the multi-user MIMO up and down, right? We're trying to get much more into, we want to start scheduling things. because we want to get more efficient, right? We want to try to get more bits onto the air.
Yeah, and I guess that's why we see these head-to-head discussions, or these articles talking about how 5G and Wi-Fi 6, they're converging, and they're I guess overlapping which one is going to win, right? So I don't really follow those discussions because they're not necessarily, I don't consider them as really fighting against each other, more so than being more complementary to each other. Unless, do you think we will see 5G indoors, inside of buildings, as being more of a dominant technology?
Yeah, so that's an interesting question, because I've been on both sides of the world, and Cisco is doing small cell and Wi-Fi, and I've always had this 5-year lunch bet. Is cellular finally going to put Wi-Fi out of business, right? Are we going to start to see small cell appear inside of our buildings? And I really don't think it's one versus the other right now. I think you're going to find that, the FCC, we have licensed spectrum that the operators buy, and they've got to monetize, that investment. And then we have this unlicensed spectrum where we see a lot more different use cases, right, that people are using. So I suspect what we're going to see is a combination of both come into the enterprise, come into our indoor life. You're going to want to have cellular for your voice, right? You look at the roots of cellular, it started with mobile voice. And for most of us, when it comes to voice, I think we all prefer LTE, right? If you want to make a voice call, your first choice is going to be LTE. But if you want to be on the internet streaming video, the Wi-Fi tends to be your first choice, right? If you tend to want to move a lot of data, you kind of want to have Wi-Fi on your system. So it's not one versus the other. And I think what we're going to see is we're going to see the operators kind of realize that, you're going to want to have as much spectrum available in the future. And I think actually an interesting data point I saw, I think if you look at the Cisco V&I data, what they're projecting is, I think by 2022, 4 or 5 years from now, half of all internet traffic is going to be mobile, and over half is going to be on some Wi-Fi network. And so that kind of tells you where the world's headed, right? We're mobile, we're headed to mobile, and we're going to be moving a lot of video traffic over Wi-Fi going forward.
Yeah, I've seen the V&I document, and I think I'll link to that in the show notes, because it is an interesting document describing how data is going to be used moving forward, and what those expectations, or not expectations, but predictions are. And talking about using, voice for LTE and data for Wi-Fi, what's really interesting to me is maybe how we will transition or roam between the two services. So my question for you is, with these advancements in Wi-Fi, I've noticed it's been very slow for different manufacturers to adopt many of the features that are currently available in the IEEE standard. What do you think would drive further adoption of these features, such as 802.11v, or even target wake time, et cetera? Like, what are you guys doing at Mist to try to, I'm sure you guys are supporting this on your access points, but even like on the client device side, what do you think it would drive more of this adoption of these features that are not mandatory?
Yeah, I mean, I think we're seeing it right now, and if you look at the kind of how wireless has evolved over the last 20 years, when I started 20 years ago at Airspace, Wi-Fi kind of started out as a nice to have, right? It was something that was actually hard to sell, right? People were trying to figure out, why do I need Wi-Fi in the enterprise? So a lot of these features we see coming down the pipe, like VR, that came from the enterprise, right? Wi-Fi inherently started as a consumer product that you used at home. It's really when we started to bring Wi-Fi into the enterprise, that we really started to add all these KVR features to actually try to solve some of the problems like fast roaming in the enterprise, right? Or try to help solve the handoff problem, right? When you're trying to roam in the enterprise and you're moving between access points. At home, you're not really roaming, right? But when you're at work roaming around, you're doing a lot more roaming. So I think what I would call the paradigm shift from nice to have, and what we're starting to see is more and more businesses put critical services on these networks. That's what's really driving all these different additions into the protocol, into the standard, right? That we're actually trying to solve a bunch of must-have critical services where people are trying to leverage Wi-Fi in ways they didn't plan to when they originally came up with the spec.
Okay. And I think that's really interesting because from with your experience, you've actually created a really big impact in this industry, because I know over the course of 20 years, you've held at least 15 patents. Which one of those would say is your favorite or most impactful to you?
Yeah, I think probably the most memory one. So when I was at Cisco, I started an industry initiative around, I don't know if you've heard of Hotspot Passpoint .11u.
Yeah.
And this is really around, can we really bring, Wi-Fi authentication on par with cellular, right? The vision that, hey, when you walk into a building, you should just connect, right?
Right.
And to your point, I really don't care whether I'm on Wi-Fi or cellular. I just want my phone to figure out, what is the best connection for what I'm trying to do. And I think we're slowly getting there, right? I mean, I think over the years, we've slowly seen, Wi-Fi kind of move from this, kind of with the, I think originally the cellular operators saw Wi-Fi as kind of a, hey, that's just a consumer toy. That's really not going to be impactful. And I don't know if you remember the early days of Verizon, right? They had these commercials where Wi-Fi was, like Wi-Fi is not going to go anywhere. And if you watched over the years, right, Wi-Fi went kind of from we'll use it in stadiums, and then it came into, yeah, but we'll never use it for voice. But if you look at all of our phones, right, I mean, all of us have voice over Wi-Fi now, right? We still prefer, cellular may be our first choice, but hey, if I can't get to a cellular network, I still want to make my phone call. So please, if Wi-Fi is available, please use it.
Yeah, I do get those types of requests where people want to have Wi-Fi calling capabilities because either cellular is just not getting into the building, or they're in some sort of sub-basement where they need some sort of calling, even for an emergency, for example. And I think, having that connection where you just walk into the premises and then you connect seamlessly, I think that's where we want to get to. I'm just not sure if a lot of the vendors make that a priority, because I know with Wi-Fi, it is sometimes a little bit more difficult to get on wireless easily without hitting some sort of roadblock, like either a splash page or like these authentication issues that happen. But I think that's where the focus will shift towards, is a little bit better experience as far as onboarding goes.
Yeah, I mean, like you said, right? I mean, I started Passpoint Hotspot 2.0 was back in 2011. It's gone slower, but if you look what's happening, right, it's now in all our AT&T phones. Every AT&T phone now has Hotspot Passpoint in it. And so what you're really watching, so I'm saying you're watching the convergence of two different worlds come together, right? Mm-hmm. We're here on one world, we have the 3GP cellular world, which has been all our mobile operators that we've known and loved over the years. And in this other world, we have this Wi-Fi IEEE world, that we've kind of come to know and love at home and work. And you're just watching these two worlds. It's almost watching two cultures come together, right?
Yeah.
I mean, have you ever gone to a conference where you have 3GPP and IEEE guys in the same room?
No, I haven't seen that.
So you kind of visualize what that world would look like, right? It'd be like trying to bring, kind of the West and the Middle East together, right? Like, let's all get together and get to know each other.
Hopefully it's civil. I would imagine it being like a West Side Story where you got two sides and.
Yeah, I mean, you can see, right? It's really two different cultures coming together. On one side we have kind of the licensed spectrum, AT&T and Verizon. They have to monetize that spectrum, right? And so they're not really motivated to embrace unlicensed. And on the unlicensed side, you have all your favorite toys that you want to make sure work and connect to the internet somehow. And it's really the mobile phone, right? That thing 2007, right? When Apple came out with that iPhone, that's what started the whole two worlds colliding together, right? Because you want cellular and Wi-Fi in these mobile devices.
Yeah, and now we just come to expect it, and that it should just work and that the latest device we purchase has the best Wi-Fi capability or the best cellular capability. And so I think these terms, these more marketing terms are starting to get a little bit muddy for some of the consumers, maybe when they hear 5G or Wi-Fi 6, but still, for us, when we think about it, it's just the same, fundamentals in wireless connectivity.
Well, I think, Wi-Fi, if you look at Wi-Fi 6 and 5G, 5G is kind of an interesting thing, right? Because it's not really a wireless protocol per se. 4G was very clear, right? 4G equaled LTE. When you say 5G, you don't really know quite. Does it equal Wi-Fi? Does it equal millimeter wave? Does it equal Rev 16 of LTE? So when you really think about 5G, what it really equals is it means, hey, I want to use as much spectrum as I can, whether it's licensed or unlicensed. So I think when you look at 5G, we are slowly getting to the point where, the operators are starting to realize that it's really about, I just want to be connected to the internet. I really don't care whether it's a cellular connection or a Wi-Fi connection. I just want to make sure that, I want the best connection available to the internet that I can get.
Yeah, and how do you feel about these operators using some of this unlicensed frequency to operate their connections for their mobile users?
If you dig into it, I don't know how, if you get into the details of it, right, there's probably a small camp that are trying to put LTE on unlicensed bands. When you think about the original purpose of unlicensed band, unlicensed did not equal Wi-Fi, right? It turned out that Wi-Fi became kind of the dominant protocol for the unlicensed spectrum. But there's other protocols that operate on the unlicensed band, right? Like BLE, right? Mm-hmm. And that's probably the other big wireless standard that is starting to become impactful in our lives, right? If you look at our phones, most of our phones have some cellular technology on it. They have Wi-Fi technology on it, and now they're starting to have BLE technology on it. So I think the operators are starting to realize that it's going to be a convergence of these different spectrums, and then there's protocols that you run on top of them. Now, putting cellular protocols on an unlicensed band, I personally think it's probably not going to work out quite like they hope it does, because inherently those LTE protocols were designed for very deterministic scheduled protocols, which require very clean controlled bandwidth, right? Wi-Fi was kind of designed for a very messy, chaotic world of, a bunch of, you weren't guaranteed to have the spectrum to yourself. You basically had to share it with others. So inherently, LTE cellular protocols were not kind of designed for this messy, unlicensed world.
Mm-hmm. And so you did mention BLE, and I kind of want to pivot here and talk about your venture now with Mist. And before we talk about some of the challenges you guys are trying to solve there and all these advancements you guys have, can you tell us the story of Mist and how Mist came to be born?
Yeah, so Mist is, like you say, is a 20-year adventure. It kind of started with my aerospace adventure back in those early 2000 timeframes. Those were the days when people were starting to bring Wi-Fi from their home into the enterprises. And so that's what I call the nice to have, right? In the early 2000s, we were really helping enterprises deal with all these Wi-Fi devices being brought into their space, and they couldn't really stop it, right? Originally, there was like, hey guys, please don't bring that Wi-Fi into work. It's a security hazard. But once they figured out they weren't going to stop people from bringing their access points into work, enterprise IT guys had to take ownership of it and bring it under control. So that's what I call the early nice to have paradigm. We were basically helping companies with controllers, right? That was kind of the controller architecture, kind of borrowed from the cellular world of how are we going to take care of thousands of access points and thousands of users inside of an enterprise. Cisco Venture was really around, and this is where I kind of started to see that transition in the market from Wi-Fi going from a nice to have to a must have. I started talking to a bunch of really big retail customers and stuff, and that's when I started to hear kind of this, hey Bob, we really got to get our controllers, first of all, I want them to be stable. I want to stop crashing. I want my controllers to stop crashing. And I really want to have visibility. That's, they were starting to put critical services on this network, like a mobile app or a robot. And that's when they wanted the paradigm shift from managing an access point to really, I'm here to help you manage the end-to-end connectivity, right? They wanted to make sure that they had visibility all the way from the user to the internet. And probably the third thing, I heard that was probably a transition that missed was really around, I want speed, and this really got into the technology transition from embedded to distributed software architectures. Their mobile app development was on a monthly cycle. Network innovation was on this yearly cycle, right? To get something new into your network, it could take a year to get that feature added. So that was kind of what I would call the market transition, was one of the reasons for missed. The other thing on the technology side, there's a couple of interesting things that happened on the technology side. I don't know if you remember the Watson Jeopardy. Remember when Watson played Jeopardy? That was kind of a technology transition of, where we finally realized that, hey, this AI stuff is really becoming real. If they can build something that can answer questions on par with a Jeopardy player, we should be able to build something that can answer questions on par with a network domain expert. So that was the other technology transition that happened. That was kind of the beginnings of Mist. Okay, we have a market transition. Wi-Fi is going from a nice to have to a must have. And then we have new technologies, and AI was one of them, and cloud was probably the other one. It's like, turns out that cloud is a much better way to maintain and develop software, right? Back in my aerospace days, we were basically developing software that went onto a 1U Linux box. When you look at the cloud, it's just a much better way. It's a faster way to develop and do software, right? Because I'm in a mode where I basically do continuous integration tests. And so basically I'm doing software every week, right? It doesn't take me 9 months to get a new feature added and a new piece of code released. I can basically update, test, and get new code released every week. So things are just moving at a much faster pace.
Okay, so when you compare that to controllers, some of those features, when we need to, install these features, that usually means a lot of downtime for people, and controllers need to reboot. APs lose their connection to the controllers. But with the cloud instance, then you can just push this update to your APs. And since there's no controller in place there, everything's managed in the cloud, you don't have those roadblocks that we have with your traditional sense of a controller.
Yeah, there's probably two aspects. What you described is the operational aspect, being able to update code without impacting users. Probably the more impactful impact is really around the difference between what I would call embedded software architectures and distributed cloud architecture, right? Back in my aerospace day, when I had to release code, I basically would take a couple of months to get the code developed. And then it could take 9 months to do the regression testing. Because it's one big monolithic piece of code, right? I had engineers checking code into one big thing. And they had this big regression test cycle. And so that is probably, and people don't maybe fully appreciate, that's the paradigm shift of, why we're watching so many things move to cloud services, right? Whether it's Salesforce.com or Workday, HR, because it turns out cloud is a much better way to do software development and actually do that whole continuous integration test.
Yeah, can you just briefly describe what regression testing is for those who don't understand?
Regression testing is basically, in the old days when we test a piece of embedded code, right? When we update the software in an AP or in a controller, we basically have to go back and test a whole bunch of features, right? Make sure we didn't break anything, right? And that's inherently because it's an embedded software architecture. It's not isolated. When we move into the cloud world, right, we're basically got all these different, very small distributed pieces of software that are talking to each other through very controlled APIs. And that's probably the paradigm shift, moving from an embedded architecture into these cloud distributed architectures, right? So once you get these little pieces of code, it's much easier to test a small piece of code, make sure you didn't break anything, and the API doesn't change, so no one else around you is dependent upon it. In the embedded world, right, but every time I touched a piece of code, I was never quite sure if I broke something, and now, how many pieces of code were really dependent upon that table, right? You updated some table, and you may find out there's another piece of code that required that table that you didn't really realize, right? Okay. And that's kind of that regression testing. That regression testing was really there to make sure you didn't break anything, right? If an engineer checked something in, did he break some other piece of code he didn't realize it was using his table?
So would you say if you're doing regression testing with now cloud infrastructure, are you less likely to come across bugs as you would doing it with the embedded?
Yeah, so when you get into the cloud world, right, the code is broken up into smaller pieces. And the code, different functions are talking through APIs to your thing. So those APIs don't change. And that's where you've got to make sure that in this cloud world, you don't change those APIs. But the smaller code provides for a smaller unit test, right? When an engineer changes that piece of code, he can basically make sure that piece of code does not break. And you pretty much guarantee, as long as you don't change the APIs, you guarantee that no one else who's dependent upon that service is going to be broken. And so that's kind of that fundamental thing when you dig into, why is this cloud distributed model a better way of doing software? Those are the details of, yes, that's why it's faster, more reliable, fewer bugs. Blast radius is smaller. If there is a bug, it doesn't blow up the whole controller. It blows up some small piece, some small function.
I think that's important for wireless engineers to understand, knowing the differences between on-prem controllers versus cloud infrastructure, cloud managed access points. I think that leads to a whole different discussion and talking about the advantages and disadvantages of both. I think that's a really interesting topic. Earlier you did mention AI, and I know wireless guys who are not. So there's a lot of wireless guys who are not software developers, but how does, I guess, maybe start with, how would you describe AI to a person like me, a guy who just configures, designs wireless? Like, why should that matter for us?
Yeah, I mean, if you look at AI is a concept that's been around for years, right? It's been around since the 50s and everything. It matters lately because it's starting to become real. And so if you look at the last 4 years, something happened probably around 2011, 14. And usually what happened was we reached a tipping point in the size of these neural networks. Neural networks have finally gotten big enough and interesting enough to solve problems. When you look at AI is the concept of doing something on par with a human. Whether it's, driving a car or trying to diagnose some medical imagery or, diagnose cancer. We're basically trying to build systems that do something on par with some human behavior that we associate with a human. In this particular case, what we're doing here at MIST is we're trying to build something on par with a network domain expert, right? So when something goes wrong in the network, right, when some user calls you up and says they're having a problem, you're in this business, right? I mean, if someone user calls you up, you have to start carrying through log files, right? You start logging things. Yeah, you start pulling down log files, looking at dashboards, trying to figure out, why is your boss having a bad connectivity experience right now? AI is really just basically a bunch of algorithms that are helping you out go through that data, right? You're looking for correlations, you're looking for anomalies in that data. It turns out that the math we have now, anomaly detection is kind of an interesting one. We've gone to like 3 different algorithms here now, right? We started with moving average, went to REMA. What we found out is when we finally got to what they call LSTM RN, this is kind of a neural network model, right? The number of false positives we've gotten to the point now of, yes, I can trust that this has actually got an answer that isn't noisy. Right, because that's probably your biggest problem, right? You've had plenty of systems that give you a bunch of events, but they generate so many events, you just get overwhelmed, right? It's like, hey, right. I can only take so many rogue. Once the system says you got 1,000 rogues in your network, it's like, okay, what are you going to do about it?
Right.
You're overwhelmed. I can't deal with 1,000 rogues.
You're just going to leave them be.
Right. I mean, there's not enough hours in the day for you to work on them.
So when it comes to AI, then, so when I was thinking about AI, the first thing that came to my mind was RRM, because it was an algorithm that looked at all the access points and determined what channels to put access points on and transmit power. Is that similar to AI, or is that kind of fundamentally different?
I would say, that's fundamentally different. Radio resource management is leveraging machine learning algorithms now. Back 20 years ago in my aerospace day when I was doing RRM, it was really around trying to minimize, the energy between the access points, right? We were adjusting channels and powers to try to minimize how well everyone saw each other, right? Nowadays, we have things like what we call reinforcement learning. And it's really about, I'm not trying to optimize, I'm actually trying to optimize the end user experience, right? And in this case here, what we're trying to optimize nowadays is we're trying to optimize the symmetry between the AP and the user, right?
Okay.
I'm trying to optimize your it doesn't do me any good to transmit more power than the user, right?
Mm-hmm.
So I'm trying to optimize the symmetry between your uplink and your downlink.
Mm-hmm.
And so that's probably the subtle difference between what we were doing 20 years ago with radio resource management, and how we're basically leveraging things like reinforcement learning now to basically optimize the end user experience versus trying to optimize some network parameter that may or may not have anything to do with your personal experience.
Okay. So then AI so I've used a dashboard, Mist dashboard before, and what I find most interesting is going in and really troubleshooting an issue. You really just put it straight into the user's dashboard and saying, "Okay, here are your root issues and who's having this issue." Is that the AI portion? Is really AI is actually going in there and finding those issues and then just telling it to me, so I don't have to go in and dig? It's doing that digging for you?
Yeah, I think there's two issues here at Mist right now. I think the first stepping stone for us is what I call troubleshooting. And that's not quite self-driving. But like here, for every support ticket that our customer success team brings in, they use Marvis and AI to try to answer that support ticket, right? To see if we can get the right answer. So that's the beginnings of AI, where you basically, ask a system, why is user X having a problem at 11 o'clock today? And the system comes back and says he's having a problem because the DHCP server is down.
Gotcha.
Right?
Okay, so it's like an Alexa, right? When we ask Alexa something,
right?
This is your version of Alexa. You type in something like, give me the reason why this device, say like your device, is having issues today between this period and this period.
Yeah, and you look at, there's layers, right? That's what I'm saying. If you look at AI, it's not just one algorithm, right? If you look at your car and look at these self-driving cars, it's a bunch of different algorithms that finally gets a car to drive by itself. The same thing in networking, right? If you look under the hood of Marvis, what we call our AI engine, there's a whole bunch of different AI algorithms, right? It starts with natural language, right? There's got to be something there to try to interpret when you ask it a question. There's a whole bunch of algorithms going through all the data, trying to look for anomalies and trying to correlate those anomalies with a user experience. That finally ends up to, yes, how often can we get the right answer? And I would say, right now, in my analogies, usually when you look at the Watson team, it took the Watson guys, 4, 5, 6 years to actually build something that could play on par with a Jeopardy champion. If I look at my adventure here, right, we're about 4 years into the venture. We're at a point now where, hey, we use Marvis for every support ticket coming in here. We're getting about half the questions right. So I think we got Marvis up to 50% accuracy. The goal is to get that up to 80% by the end of the year. And that's kind of where we are in this AI journey, right? And I think you're going to start to see that in the industry, right? We're at the very beginnings of, yes, these AI solutions are just starting to come out. They're starting to make a difference. Hopefully they're going to make your life easier, right? They're going to give you.
And I think that's where the biggest impact will be this year and maybe next year, is AI being able to help people who may not even be wireless experts, right? Wireless, I know when I've worked with like help desk people, they still have the challenges of even trying to figure out what the problem might be. But with AI, if they can narrow that down at a faster, time to resolution, then that's already a big improvement for a lot of organizations.
Yeah, I mean, and most of us don't realize it. It's sneaking into our lives without us really. I mean, I don't know if you look back into these automated help desks, press 0, press 1, press 5. If you actually look at those are actually getting better. And that's because, if you look behind it, there's some AI that's getting much more intuitive about what you want, right? And that experience is starting to come into your life. If you think about all those help desks of, for me, it's like when I pay my monthly Visa bill now, right? It's gotten better. If you actually think about it, it's like it's still, all those automated calls are starting to get better, and that's because the AI system behind them are actually getting more and more like a real human.
And earlier you mentioned machine learning. So how does that play into Wi-Fi today? And I know I have not heard anyone really talking too deeply about this topic and how it applies to Wi-Fi.
Yeah, for me personally, location is probably one example where, 20 years ago, I've always been on, the other thing I've always been on the mission is like, can we bring indoor location on par with GPS? Can we get this kind of, can we get to the point where indoor location is just standard on our mobile devices? 20 years ago, there's always been this survey, right? You always had to learn the path loss model, right? The relationship between RSSI and distance. That's something you typically had to go do a site survey, right? You had to walk around and you collect a bunch of data and you try to figure out what we call path loss model, right? Nowadays, at MIST, I was able to solve that problem with what they call unsupervised machine learning, right? I was able to take all that RSSI information and actually learn the path loss between every mobile phone and every AP just by analyzing that data. So that's an example where, machine learning, where I got to enough horsepower, right? Besides my Amazon bill, how much it's going to cost me, I didn't have any CPU limitations. I could basically had enough horsepower where I could actually get that algorithm to work. I think anomaly detection is the other big thing that is really going to change now. And this is the advent of neural networks. As I said before, we've been playing around with anomaly detection for probably the last 2 or 3 years. We started with moving averages. Can we just look at the moving average and decide if there's an anomaly? It's too many false positives, right? We got, it would waste your time, right? We'd give you too many false positives of what we think is an anomaly. Then we tried something called ARIMA. And that was good. That got us to 80%. That's still too many, that's too many false positives for the average IT guy to deal with. It wasn't really until we got to these LSTM, what they call long-term short memory neural networks, where we finally got to a rate at which, the false positives are very, very low now. Like, when we find an anomaly, 99 out of 100 times, yes, it's something you should take a look at. So that's another example where, yes, machine learning is actually starting to make a difference in the networking world. And we've seen it in the other world, right? We know when it comes to image classification, right? The classic cat dog, right? That's all because those neural networks are getting powerful enough where they can actually do a lot of computer vision. Is becoming useful.
When you're doing these calculations and determining location, and because you're able to now really determine accurately of where a device is, does that change what type of hardware you need in the actual access point itself?
Yeah, I mean, I think that's probably another topic. It's probably another good podcast. Is if you look at our wireless world, Wi-Fi and cellular are connectivity. When we want to get connected to the internet, it's usually through cellular or Wi-Fi. When you think about indoor location, it's really if you look at what's stopping an indoor location from becoming a must-have, it's really the technology in our phones, right? Now, so far, BLE is that technology. Between Apple and Google and Samsung, all our devices now have BLE. BLE looks to be currently the technology of choice for proximity location type of use cases. Now, I think that may change. I think there's other location technologies coming down the pipe. Ultra wideband, .11nc. Angle variable for BLE, right? But it really depends on Apple and Google, right? Which of these technologies are the mobile device vendors really going to adopt? And this is something for you, right? This is something for the wireless. It kind of reminds me of the early days of Wi-Fi, right? When it was a nice to have, IT guys are like, why do I have to deal with this? Indoor location is probably the next nice to have. Is why do I need it? This is something new. This will be something that the IT guy will have to start dealing with. As indoor location goes from a nice to have to a must have.
Yeah, and also like with the shift of Wi-Fi and society over the course of 20 years, right? I thought a couple of years ago, location was really important. People wanted that location, but now we're in the shift where people want more privacy and not necessarily want to be tracked. I guess you're not really tracking them per se, but you're just really using the location-based services to really boost experience. Right. People have this privacy issue. How does that play with you and Mist, and how do you handle those types of concerns people have?
Yeah, so I think when privacy and I think location in general, right? I don't think anybody would give up their GPS location, right? So I think privacy is more of an opt-in thing, and so if you look at Google and Apple, right? It's more about people want to make sure that no one is doing anything without their permission. Mm-hmm. And so Google and Apple have done a pretty good job nowadays of making sure that nothing on your mobile device is doing anything without your permission. So there's kind of a privacy framework that's evolved from the industry out of need. So I think in that sense, Google and Apple have done a good job of making sure that our privacies are not being abused, right? Whenever you put an app on your phone, your phone will let you know if it's using location and has your permission to use your location.
Right. Yeah, because I know on my Apple device, I can see a little icon that shows, hey, there's an application using your
right.
GPS.
Right. And I think people are going to want location services, right? And just like, I don't think anyone's going to argue with 911. I mean, when you need help, it says, please use my location to come find me. If I want to navigate my way, somewhere, yes, I want to use location to figure out how to get to point B. So I think indoor location is going to be another one of these evolutions between technology. I think there's definitely market demand, right? There's definitely a need of, yes, when I'm inside of a big building, yes, I want to know where I am and I want to know how to get to the other side of the convention center.
Yeah.
I want to know how to find my mom, or I want to know what's around me.
I think the convention center case is one that I know I've used at previous conferences is okay, I need to get to this location. How do I get there from here? Because I have to navigate the traffic of not knowing where to go. But I would say that's the one that relates most to me. I guess looking back at how this technology has evolved and where you guys are going, what do you think could have been done better, either at like the IEEE or Wi-Fi Alliance level, or as an industry as a whole?
I think overall, when you look at all what it takes to kind of get to the level of Wi-Fi, I mean, I think first of all, we all have to kind of, appreciate what the Wi-Fi Alliance did, right? That was probably one of the key milestones in the adventure. A lot of standards never get past that, right? Zigbee, ultra wideband. That was really where the Wi-Fi Alliance created a standard, right? Got everyone to agree to interoperability. So I think that was a critical thing, what we did well, right? Because I think people don't really appreciate it. It's one thing to have a standard. It's another thing to be interoperable, right? Yes, you can create a standard, but if you never get to interoperability, you'll never get to an ecosystem like Wi-Fi. So, I mean, I think overall, I think everyone should take a moment, smell the roses, have a sip of wine. It's like, guys, it's been an amazing 20 years when you think about all the hurdles we got over with, right? We got to technology, got to an ecosystem that is amazing, right? FCC created the unlicensed rules to take advantage of it. Wi-Fi emerged as the protocol of choice for this unlicensed band. If I look on terms of better, I think now we, in the hindsight, back to the two worlds, right? We have two worlds we're living in. I have my cellular world, which is kind of my outdoor internet connectivity world. I have Wi-Fi as kind of my indoor. We probably could have done a better job as an industry in bringing these two worlds together, right? And this is what I call back to the IEEE 3GPP. How do we get these two worlds to talk, communicate? It's not one versus the other. It's like we need both of these worlds to actually work together to get the internet experience we really want.
Okay, I think that leads perfectly into a question I have for you is, what do you think the future of Wi-Fi will look like in 5 or even 10 or even the next 20 years?
Yes, I mean, I think Wi-Fi and cellular are going to start converging more together going forward. I think 5G is the very first step of that. I think we're starting to see that, it's not about the, new wireless, it's not about LTE versus Wi-Fi. It's more about the connection experience. So I think we're going to start to see more evolution around how we get these two worlds to roam together, whether it's Passpoint or some other roaming scheme that comes our way. I think we'll see new bands, right? We'll see millimeter wave. When I was at Cisco, I invested in a company called Velocity, 60 gigs. 60 gigs really never got into our phones. They're a little too expensive. We don't have millimeter wave in our phones. But I think we'll see more spectrum get into our phones. I think the other thing I didn't mention, I think everyone's aware of the 6 gigs, right? The FCC. The FCC is bringing another whole gigahertz of unlicensed spectrum to the party in around the 6 gig band. And so I think we're going to see that. We're going to see an evolution of how to leverage all the spectrum available. We're going to see more spectrum getting into our phones going forward.
Cool. Well, Bob, I want to say thank you for joining us here on the podcast. I thought this was a great discussion talking about the history of Wi-Fi, how you've gone from, starting at this other, where you got your beginnings in the startup, and then going now in the future to a new startup, but developing something quite different from what we've had over the past 20 years, such as AI and location-based services and even machine learning. I think that's really interesting, and I'm looking forward to seeing how that progresses and how we can better make better wireless networks. Where can people find you and learn more if they want to learn more about AI and machine learning and basically wireless?
Yeah, well, so personally, anything that has to do with wireless, indoor location, AI, or wine, you just come at bob@mist.com. That's always a good way to get hold of me. I think, when you look out in the industry, right, there's plenty of information out, on the internet. I think Cisco VNA, that's a good place to look at where the world's headed. But yeah, I encourage anybody who wants to learn more. I'm always open. So bob@mist.com is a good way to get hold of me.
Awesome. Well, thanks again for joining us on the show. It was a pleasure speaking to you, and I look forward to seeing you at the next conference.
Yeah, same here. Thank you, Rowell.